CCNA level of EIGRP recap. EIGRP is one of the advanced distance vector routing protocol, enhanced interior gateway routing protocol. This comes under advanced distance vector. Sorry, some portions were not recorded. I'll repeat again. EIGRP Cisco protocol. It's an advanced distance vector routing protocol, and it has got composite metric. Why we call it as composite? Because more than one entity is there, bandwidth and delay, and load and reliability in MTUs are not considered. And I explained to you these things. Now, administrative distance, there are two. One is internal 90, another one is external 170, which I explained just now. I'll repeat again for the recording sake. When we advertise using network command, then it is internal. When you take from some other routing protocol and give it to EIGRP, those routes are considered as external. Internal has got more weightage than external. That's why the number is 90 and 170. With respect to the administrative distance, smaller number is more prioritized, more weightage than the larger one. EIGRP uses this algorithm called diffusing update algorithm, using which the best and loop-free path for each destination has been discovered and installed into the routing table. Dual algorithm, diffusing update algorithm. Like all other protocol, EIGRP supports equal cost load balancing, but additionally, this can also support unequal cost load balancing. You see, this is a special one where no other protocols does this. But again, EIGRP also don't do this by default. If you want to enable this, you have to tune EIGRP, which we'll be learning in CCNP level. But you should know that EIGRP can support unequal cost paths. According to the capacity, they will do the load sharing. Unequal cost, load balancing. And then EIGRP is a classless routing protocol. So this can support classless routing. Like if you have a VLSM, variable length subnet mask. You know what is variable length subnet mask. We learned in detail. So the subnetted network, not a class full. The mask is of various size. That's why we call variable length. That's the length of the mask. /20, /22, 23, 24, 30, /16, variable length, /10, /11 for the same network. Different length of mask. EIGRP is a classless routing protocol. It can understand all those lengths and it can effectively work and provide a loop-free path for each VLSM network. Now, EIGRP uses a protocol. This point I have not explained in the previous classes. This is one of the points from CCNP syllabus, but I just want to say in this class, EIGRP, when you enable, there is a protocol called RTP, Reliable Transport Protocol. This protocol works automatically you no need to enable this RTP. You enable EIGRP, RTP will start running. RTP will start providing routes with guaranteed delivery. RTP will make sure that no routes are missed out during the advertisement. See, this is an IP protocol. EIGRP works in which layer, in OSI? It works in layer 3. See, if it is layer 4, you have TCP to provide connection oriented. But this is a layer 3 protocol. EIGRP is a layer 3 protocol. So there is a need for some guaranteed delivery. RTP does that. RTP provides that guaranteed delivery. Reliable Transport Protocol. RTP. Layer 3. EIGRP is a layer 3 protocol. So you need additional support to provide reliability. That's why RTP gets enabled. This is not a real-time protocol. There is another protocol called RTP, which is a voice protocol, real-time protocol. Hey, we are not talking about real-time protocol here. This is reliable transport protocol. See, the word explains what it does. Reliable transport, guarantee delivery of EIGRP updates. Now, EIGRP send hello packets every 5 seconds to a multicast address 224.00.10. And using the hello packets, the neighbors are discovered, and neighbors are learned in a table called neighbor table. EIGRP maintains 3 tables, as usual, one routing table, and the other 2 are neighbor table and the topology table. We have a routing table, which you know. We now have additionally neighbor table, where neighbors are maintained, and topology table. So these 3 tables are there. Now, how the neighbor table is updated? When hello packets come from neighbor, if the neighbor is also in same subnet and same autonomous system, they form neighbor. I told you, EIGRP forms group, autonomous system, groups. So the neighbors are maintained in neighbor table. After forming neighbor, they share the routes that they have. That is maintained in topology table. Now, even after forming neighbor, the hello packets will be sent every 5 seconds to maintain the neighborship, to maintain the adjacency. Right? Now, if you want, okay, now next is the dead timer. The dead timer is 15 seconds. If a neighbor is not saying hello, if the neighbor is not saying hello for 15 seconds, the neighbor will be thrown out from the neighbor table. All the routes learned from the neighbor will be also removed, if any present. Actually, whenever the change happens, a trigger update will come and remove those routes instantly. It is not going to wait for 15 seconds or 5 seconds or like a RIP 240 seconds. This will throw immediately. In case if something is left, that will also get removed after this 15 seconds. Yeah. So hello packets are sent every 5 seconds. Next. This is a Cisco protocol. Even today it is a Cisco protocol, but not a proprietary. Once it was a proprietary protocol, but now it is made as open so that anyone can use it. So it's no more called as proprietary protocol. But again, it is still a Cisco protocol. Cisco developed it. Right. So these are the main points about EIGRP. Let's quickly do one small lab as a recap, and then we will talk about the protocol. A nice topology to test EIGRP. We have 3 routers and different mask length. You can see /16 in between R mid and router RA, and then /24 length R mid and RB. And we got loopbacks with 32 masks, and we are going to run EIGRP to distribute the routes. No static route, no default route, no RIP, EIGRP. And we are going to see how the routes are learned. Now, we'll start from this router mid. Our mid interface loopback is 3.3.3.3. And then interface gig 001 on the top. IP address will be 10.12.0.03. That's what I mentioned, the dot 3. And the mask is 16. Is it 16? Yeah, 16, 255.0.0. Now, the other interface will have 24, same 10, but the second and third octets are not the same. So I'm saying interface gig 000, no chat, IP address is 13.13.13.0, 24 mask. This is what we call VLSM, different length of mask. Now, finished configuring the basic. EIGRP will come second round. Let's finish router A. Enable config T hostname RA. Interface loopback 0. IP address is 101.1. And then interface G000, 10.12.0.1. Done. Next. Done. So we have finished configuring the basics. Let's go to our mid ones and check the routing table with the masks with different length. You can see here same 10 network, one is with 16, another one with 24. Now EIGRP should support this VLSM because it's a classless routing protocol. Let's enable EIGRP router, EIGRP. I'm going to give autonomous system number. This can be any number between 1 to 65535. I would like to give 111 for once. And you should repeat the same number on the other routers. Next is I want to say all the interface that has got 10. I'm not particular about the second and third octet. I'm saying if you see the first octet 10, start running EIGRP. So because of this, EIGRP now will be running on both 10, 12, 0, 0, 10, 13, 13, 0. Because both starts with 10. Another one is network. If you see any address starting with 3, run EIGRP. Or if you say, no, I don't want to say all 3, I want to say only if it matches 3.3.3.3. All 4 numbers should be 3. Then you need to put wildcard mask. This is to say that 4 numbers should be 333 on the interface IP. Only then EIGRP should run. Whereas this one, you say just check the first octet, second, third octet, second and third and fourth octet, doesn't matter what number it will have on the interface. So that wildcard mask stuff. These things will repeat again in CCNP, and we'll have more better, bigger scenarios, bigger examples. Now, then, the verification command show IP EIGRP interfaces. You should see 3 interfaces. You see, loopback G000, loopback G001, and loopback. Sorry, not loopback. 1 loopback and 2 gig Ethernet. 00 gig 001, gig 000, and loopback 0. These all 3 are running EIGRP. So far, no peer has been discovered because the other routers are still not configured with EIGRP. So let's go to other routers. Configure EIGRP quickly. Router EIGRP 4 times 1, and then network. I can also say like this 1.100.001. Oh, wait a minute. Network. Actual mask is 32 there on the interface. You can see on the picture. But I can also say like this 1.1.0.0.0.255.25. What does this mean? It means that first 2 numbers should be 1.1. And 255 octets, not the third and fourth octet. These 2 octets can be any number. That's the meaning of this. 255 means don't care bits. Wildcard mask, don't care bits. Okay, now the other network is 10. No need to say 12 and all. Okay, then finished on RA. Let's go to RB. Router EIGRP 1111, network 2.0.0. I say just 2 if it matches. Run EIGRP, network 10. Done. Now if you go back to router mid, you should see 2 peers. One via this interface, one via this interface. Now you can check it in another command, show IP EIGRP neighbor. You see, there are 2 neighbors, 0th neighbor and the first neighbor. This is the 0th neighbor. You know why? Because I configured RA first, the top route. And then I came to RB. This is the RB's address. And you see the timer here. I even showed these things in the previous class. See, after 14, the countdown, 11, again 10, again 14. What does it mean? Countdown starts from 15, and every 5 seconds, hello is coming. If the hello doesn't come, it goes to 0, and then the removal happens. Right. So that's one table. Show IP EIGRP topology. This is another table. It shows all the networks in your routers. All the networks in your topology. Show IP EIGRP topology. And about the routing table, you know very well, show IP route. You see, you have learned through dual algorithm EIGRP, administrative distance is 90. This is the composite metric, combination of bandwidth and delay. Now, we'll be able to ping from RB to RA. It is because EIGRP route show IP route, you can see the route to reach EIGRP, 1111 is given by EIGRP. You can trace route and see. Trace route, show me the route. It says I'm going to router mid first, this is mid router, and then to the final destination. See, show IP route will show you the complete routing table, but if you want to see only the EIGRP routes, you see right now you have EIGRP routes, connected routes. If you want to filter it out, you can say show IP route EIGRP. It will show only the EIGRP route. Same command is available for RIP. Show IP route RIP, show IP route OSPF, show IP route BGP. You can filter based on the protocol. Right, we have come to this end of EIGRP